Hello, can you hear me? Hello, I hope you can hear me. Okay, let's start with the problems. This is the race sheet for straight lines and circles. So tell me which questions you have not been able to do. We'll discuss those problems. This is RA6, the sheet that I had shared on straight lines and circles. You can share your doubts and we'll discuss those problems. You have to either speak up or type in the chat. If you're quiet, then I don't know what you want to discuss. Javed, do you have any questions? Nobody has any questions, huh?
Sir, I have questions, sir. So, was unable to do number 6 and number 8.
Okay. Uh, question number 6 we'll look at first. Right. The radius of the circle touching, 1 second. If the radius of circle touching x minus 2 whole square plus y square is equal to 1, and the angle bisectors of the transverse common tangents and the angle bisectors of the transverse common tangents of x plus minus 2 whole square plus y square equals 1 is p plus minus root q. Is p plus minus root q. You have to find p and q. So the main thing here is to understand what the question means. If you understand the question properly, then only you can do it. So we have to find the radius of a circle which touches this circle and also touches two lines. What are the two lines? The lines are the angle bisectors of the transverse common tangents. So think about it. Transverse common tangents will be to two circles. So that's why they have given you two circles here. This is not one circle. These are two circles, right? Correct?
Yes, sir.
So if there are two circle equations, we can find transverse common tangent equations. Once you find the transverse common tangent equations, then you have to find angle bisectors of those TCTs, right? Correct?
Yes, sir.
Once you have found the angle bisectors, then I have that there is a circle which touches the two angle bisectors that you found in step 2, also touches the given circle here, this circle, right? correct?
Okay, sir.
We have to find the radius of this circle. So obviously the first two steps are compulsory here, these things, right? Without that, you can't do anything, correct?
Yes, sir.
So draw the circle equation, draw the graph for the circle, and then you can think about transverse common tangents. So let's say my first circle is x plus 2 whole square plus y square equals 1, and the second circle is x minus 2 whole square plus y square equals 1, right? So it will look somewhat like this. One circle has center at 2 comma 0. The other circle has center at minus 2 comma 0, right? Correct.
Yes, sir, yes.
And radius of both the circles is 1. So it will be like this, one circle, and like this, another equal circle, right? Correct,
Right.
no?
Yes, sir.
Now transverse tangents to this, you should see that it will look like this, right?
Yes, sir.
Correct.
Yes, sir.
Transverse common tangents will look like this. And then you should, by the figure only, you should realize that both the transverse common tangents will pass through the origin. Do you know how I know that?
Sir, by using similarity.
And notice the radius is same, no? So these triangles
Yes,
are congruent, right?
yes, sir.
So the midpoint, they will pass through this midpoint. This side is midpoint, right?
Yes, sir. So it will be 2 units away from the.
Right. And therefore the transverse common tangents, it almost looks like you can sort of say that they will be of the form y is equal to mx first of all, right? And the slope also can be obtained because you can see radius of this circle is 1 and this distance is 2, right? So
Yes,
we
sir.
can figure out this angle, no? Do you understand what I'm saying?
Yes, sir.
So you can easily find the equation of these tangents because this angle is known, correct?
Yes, sir.
Tan theta is what? So it is coming as this is 90, this is theta, this is perpendicular, and this is hypotenuse. This angle is 30-degree,
30
right?
degrees. Yes, sir.
So the circle, the tangent equations will be plus minus 1 by root 3x, right?
Yes, sir.
Now the angle bisectors of these two will be very easy. One bisector is this, one bisector is this, right?
Right.
Do you understand why? Because this angle is
Yes, sir.
60, so one bisector will be this line, x-axis,
X-axis.
and the other bisector will be perpendicular to one bisector, so it will be y-axis, right?
Yes, sir.
So my two angle bisectors are x-axis and y-axis, correct?
All right. Yes, sir.
And I have to find a circle that touches x-axis and y-axis and also touches the given circle, right?
Yes, sir.
Given circle is x minus 2 whole square plus y square equals 1. And any circle that touches x-axis and y-axis will have center at r comma r, right? The equation should be something like this. Do you understand?
Right. Yes, sir.
R could be plus or minus, by the way, because it could be circle this side or this side, right?
Yes.
In this case, it will be this side and it will be like this because it touches this circle. Something like this will happen, right?
All right.
Do you understand what I'm saying?
Yes, sir.
And now notice, no, actually it is this side because x minus 2 whole square plus y square is this circle, right? Actually it is this side, no? See? Because this circle is this one, no?
Oh, yes, sir.
So, okay, I know the equation of circle has to look like this because it touches the x and y axis both. Now I have to do C1, C2 is equal to R1 plus R2, right? For touching two circles.
Yes.
The center of my unknown circle is R comma R. This center is 2 comma 0. Radius of this circle is 1. Radius of this circle is R, right?
Yes, sir.
So it's a simple equation which gives us the R value now, right?
Yes, sir.
Do you understand what I'm saying?
Yes, sir.
So the main idea is to look at the question and try to understand what they mean. You have to read it carefully and try to draw the figure, then only you'll get it. Okay. After
Yes, sir. I
this
was not
point,
able to like formulate the diagram. That's why.
so that's because when they said transverse common tangents of the circles, maybe you have forgotten that the equation was spelling out two different circles, right?
Yes. No, so like I was not able to understand how the other circle would look, where the
Okay.
other circle would be placed.
So if you have got an angle, did you get angle bisectors or x-axis, y-axis?
No, sir, that I was not able to visualize. I didn't draw the coordinate systems. That's why.
So if you don't draw the figure, you'll be stuck, right?
Yes, sir.
These two circles, you have to draw the figure. Then only you can draw transverse and common tangents,
Yes, sir.
right? If you draw the figure, then only you will get the hang of it. Otherwise, if without drawing a figure, don't try to attempt these questions.
All right.
It is always better to draw the figure because then you get a sense of what is the path. Otherwise, it will be stuck.
Right.
Okay. Next one is eighth one.
Yes, sir.
If the length of the chord AB is 4 as shown in the figure, find the area of the shaded region. Okay. Okay. There is a big circle. There are two smaller circles inside it, which are touching. And there is a chord which is also common tangent. This is the chord AB. Okay. And they are asking you to find the area of the shaded region. Okay. Shaded region is everything except these two inner circles. Fine. So what have you tried here?
Sir, I tried to like draw the diameter of the circle and make two triangles.
Mhm.
But so like after that, I was not able to proceed.
Draw the diameter. Hmm.
So the line passing through the center of the circle.
Okay, so this is a point which is special because it is the point where the two circles touch each other, also where the line is tangent, right? AB is like the common tangent of the two inner circles, right?
Oh, yes.
That you should realize.
Oh, sir, I haven't realized.
But that is obvious from the figure, no? Otherwise,
Yes,
that
sir.
doesn't make sense, right?
Yes, sir.
Let's join a line perpendicular to AB like this. So notice that AB is a chord and this line that I have drawn is perpendicular to the chord, right?
Right.
What I'm saying is, if we have not been given that this point is midpoint of the chord, but I'm going to assume that. See, the question doesn't have enough data, first of all. They should say that this point is the midpoint of the chord. Do you
Yes, sir.
understand what I'm saying?
Yes, sir.
Because if they don't say that, then we don't know whether this line is diameter or not, right?
Yes, sir.
But if they had told us that the point of contact of the two circles is the midpoint of the chord, then we can draw a line perpendicular to that chord. Then that line which is perpendicular to a chord and passes through the midpoint of a chord will always pass through the center, right?
Yes, sir.
So in that case, this line will become a diameter, right?
Right, sir.
They have not mentioned it, but I think they should. So I'm going to assume it, and I'm going to assume this line is the diameter, right?
Yes.
They should mention it, but they haven't. So maybe there is something missing in the question. But let's think about it anyway now. We can say if this circle has radius x, let's say radius of this circle is x and radius of this circle is y. So this distance is what? 2x, and this distance is what? 2y, right? Correct?
Yes, sir.
Now notice if you call this point T, let's call this point T. T is a point that is internal to the big circle, internal to the big circle, right? Now, do you know about the concept of power of a point? Power of a
Right.
point with respect to a circle?
So it is basically like the
Hmm.
square of the tangent, length of the tangent.
So basically the idea is if the circle is given and a point is given, then any chord through that point passing through the circle and cutting it at two different points will have the same product of lengths, right?
Yes, sir.
So basically what it means is PC times PD is equal to the same as PE times PF, right?
Right, sir.
As long as the point is fixed and circle is fixed, it doesn't matter how you take the chord, right?
Right.
And sometimes you can even take the chord and make the chord become a tangent, right?
Yes, sir.
And notice that instead of C and D separate points, they become the same point T and T, right?
Yes, sir.
So it becomes PT into PT or PT square, right?
Yes, sir.
Which is length of the tangent.
Hmm.
Correct, no?
Yes, sir. Yes.
But this power of a point concept is not limited to just points outside the circle. You can also take power of a point when it is inside the circle, because you can draw a chord through it and P is this point and let's say this is C and this is D. You can still say that PC into PD is the power of a point, right?
Oh, all right, sir.
This is a standard geometry idea. Power of a point can be written as point to the center of the circle minus radius square, right?
Yes, sir.
That will still be valid even if the point is internal, by the way.
Oh, okay, sir.
The power of a point will become negative in that case, right?
Yes, sir.
Power of a point is zero if it is on the circle,
So,
negative if it is inside, and positive if it is outside. Do you know that?
oh, yes, so we use this idea to find the location of a point with respect to a circle.
Right. So
Yes.
it's the same concept, whether point is outside or inside, you can still use power of a point. And now notice that I have a point T, right? I can say power of point T will be TA times TB, right?
Yes, sir.
But it should also be T into this distance times T into this distance, right?
Yes, sir.
Notice that those distances are 2x into 2y, right?
Yes.
And TA times TB, I'm assuming that these are midpoints. I have already made that assumption, by the way, right?
Yes, sir.
So therefore, it will be 2 into 2, no? Because the whole length was 4.
Yes, sir.
So you'll get 4xy is equal to 4, right? Correct?
Yes, sir.
So you're getting xy equals
So equal to
1.
1.
So that is one piece of information. Let's see what they're asking us. They're asking us for area of the shaded region. I know xy equals to 1. And now I have to find the area of the shaded region. So let's focus our attention on the big circle. The total circle has radius how much?
X.
No, biggest circle.
Oh, biggest circle.
The radius of the biggest circle will be half of the diameter, no?
Oh, yes, sir. So
X plus y, right?
x plus y.
Pi into x plus y whole square minus. Subtract the areas of the two known circles. Is this going to be the correct area?
Yes, sir.
So take pi common, you will realize it will be x plus y whole square minus x square minus y square. So that is 2xy, right?
Right, sir.
And we know what?
X y is 1, so 2 pi.
Hmm. So the question is based on, see, nobody can find the answer if they don't use the power of a point concept here, right?
Yes.
You will be stuck with this 2 pi xy, right?
Yes.
The concept is also useful in this case only because we have made an assumption that t is the midpoint of AB, right?
Yes.
If t is not the midpoint of AB, problem is much harder because this line is not the diameter and all, right?
Yes.
So they have forgot to mention that you have to assume. And after
Right.
that, you have to use the concept of power of a point, that point P was internal, T was internal to the circle. Then the chord TA times TB is same as T into this P times T into Q.
Yes.
No matter where you are, you can always prove this. PC times PD is same as PE times PF. Okay.
Right.
And
Yes.
if you don't know the proofs, you should check it out online. The proof is based on similar triangles. You will be able to prove it. Okay.
Okay, sir.
So that is the solution for this one. Tell me what is the next doubt?
So just a second.
Hmm.
So the numerical type, section 3, number
Hmm.
2 and 3, sir.
Okay. Question number 2. A ray of light incident at the point -3, -2 gets reflected from the tangent. Okay. So ray incident at -3, -2 gets reflected from the tangent at 0, -2 to the circle. Gets reflected from the tangent at 0, -2 to the circle. The circle equation is given x square plus y square equals 4. Okay. Then they are saying reflected ray touches the circle. Okay. The reflected ray touches the circle, and the circle that they are talking about is the same circle, right? Okay. The equation of the line along which the incident ray moved. You have to find the equation of the incident ray. The equation of incident ray. Okay. So first of all, the tangent at 0, -2 to the circle is easy to find the equation. See, x into 0 plus y into -2 is equal to 4, right?
Yes.
So y is equal to -2 is the equation of this line, tangent. So ray incident at -3, -2 gets reflected from the tangent at this. So y is equal to -2 line, it gets reflected from there. So let's draw a rough figure. The circle is like this. Y is equal to -2 line is this. And the ray is incident at -3, -2, somewhere here. Like this, right? And the reflected ray touches the circle. That's why I have drawn it like this, right? Do you understand what I'm saying?
Yes.
This is the point of incidence. This is the incident ray whose equation we need to find. And this is the reflected ray. Reflected ray is tangent to the circle. Correct?
Yes, sir.
Okay. So we have to make the equation of a tangent from this point to this circle. Basically, we have a pair of tangents here. One tangent is this, y is equal to -2, right? And
Right.
this is the second tangent, correct?
Yes, sir.
Okay. And from there, we have to figure out this ray's equation. Okay. We can find this equation of reflected ray by using SS1 is equal to T square concept, right?
Yes, sir.
See, this concept gives us equation of pair of tangents, right?
Yes, sir.
From an external point, right?
Right.
And we already know one tangent. So we can then take out the factor of y plus 2 and get the remaining tangent equation, right?
Oh, okay.
Do you understand, no, what I'm saying?
Yes, yes.
So if you know the pair equation and one tangent you already know, then second tangent is obvious, right? So
Right.
let's use that concept. We don't need to figure out too much here. It's a straightforward idea to use this idea, to use this equation. So equation of the circle is x square plus y square is equal to 4. So S is this. S1 would be putting this point into the circle, right? Correct?
Yes, sir.
So it would be 9 plus 4 minus 4 is equal to t square. T is the tangent equation with respect to this point. So it would be minus 3x minus 2y minus 4 whole square, right? Are you understanding?
Yes, sir.
So this equation is coming now, and this equation is becoming 9x square plus 9y square minus 36 is equal to, let's square this side also, 9x square plus 4y square plus 16. Okay, we can have taken all the minuses outside. Minus is gone, so everything is plus now. 12xy plus 24x plus 16y, right?
Yes, sir.
So 9x square gets cancelled and you will be left with some stuff. Let's write it on one side. 5y square minus 12xy. So this and this is gone, this is gone. Minus 24x minus 16y and minus 16, so minus 52 equals 0, right?
Yes, sir.
This is the equation of my pair of tangents. So if my second tangent was ax plus by plus c, if I multiply that with y plus 2, that should be same as this equation, right?
Yes, sir.
Correct?
Right. Yes.
So let's do that calculation now. You will get by square plus axy plus cy plus 2ax plus 2by plus 2c. And collecting all the terms, you have by square, there's no other thing. Axy is also here fixed. Y term is c plus 2b. By square plus axy plus c plus 2b times y, right? And x terms is just 2ax, correct?
Yes, sir.
Plus a 2c. And now we can compare it. From here, it is obvious that b is equal to 5, right?
Right.
A is equal to minus 12, it seems.
Yes, sir. Minus 1.
And c plus 2b should be equal to minus 16, right? C plus 2b. So c plus 10 is equal to minus 16, right?
Yes, sir.
2c,
Maybe minus 26.
c is coming in minus 26 and it should fit the remaining constants also, right?
Yes, sir.
2a is also fitting and 2c is also
Yes,
fitting
sir.
now, right?
Yes, sir.
So equation of our tangent has come. It is minus 12x plus 5y minus 26 is 0, right?
Right.
And this tangent, notice that this point should lie on the tangent, right? So see, it is lying 36 minus 10.
Yes, sir.
Great. So we know the equation of the reflected ray we need to now find the equation of the incident ray, right?
Right.
And notice the easy way to think about it is the angle of incidence will be equal to angle of reflection, right?
Yes, sir.
This line, which is line x is equal to -3, will be my normal line, right?
Yes, sir.
Because the mirror is parallel to x-axis, the normal will be parallel to y-axis, right?
Yes, sir.
And now it should be obvious because notice that x is equal to -3, I can find out this angle, right? Why? Because I already know this angle, theta. Theta is the slope of this line,
Oh, yes, sir. Right.
correct? So
Yes, sir.
my angle here is 90 minus theta,
Minus
no?
theta. Yes, sir.
So I already know tan theta is my 12 by 5, correct?
Yes, sir.
So this angle is 90 minus theta. So this angle is 90 minus theta, right?
Right.
So my incident ray is making what angle? It is making 90 minus 90 plus 2, 90 minus 90 plus, so 180 minus theta angle, right?
Yes.
With the x-axis, right?
Right.
So my slope of the incident ray will be tan of this angle. So it will be minus 12 by 5,
Oh,
right?
yes, sir.
My incident ray slope should be minus 12 by 5 and it passes through this point. So point slope form, right? Do you understand what I'm doing?
Yes, sir.
I'm not doing something too complicated. I'm not trying to find bisectors or anything, right?
Yes, sir.
I'm doing simple stuff, geometry. I already know slope of this line tan theta. So I can find out this is 90 minus theta, this is 90 minus theta. So overall angle here is 180 minus theta,
Minus theta. Yes, sir.
right? So I need slope of that line. So that will be basically tan of 180 minus theta, right?
Yes, sir.
Minus 12 by 5 is the slope. Equation would be y minus minus 2. So this is equal to minus 12 by 5 x plus 3. Correct?
Yes, sir.
I hope you are understanding.
Yes, sir. I understand.
Okay, let's move on to the next one. Question 3. The line L1, 3x plus 4y plus 12, is rotated anti-clockwise by some angle about the point where it intersects the x-axis. The line obtained in new position is denoted as L2. Okay. If the incenter of triangle formed by L1, L2, and y-axis is this, find the value of, okay, fine. So line L1 is 3x plus 4y plus 12 is 0. And it is rotated by tan inverse, how much? 24 by 7 anti-clockwise about the point, where it intersects the x-axis. So y is equal to 0, x-axis will be minus 4 comma 0, right? Correct, no?
Yes, sir.
New position, new equation of the line, new line is L2. Great. So, okay. And now I have to find in center of the triangle formed by L1, L2 and y-axis. Correct?
Yes, sir.
So this line looks like what? It's a line with all the intercepts are negative, by the way. X-intercept is -4, y-intercept is -3, right?
Yes, sir.
Something like this it will look like, right?
Right.
And it passes through this point, and now you have to rotate the line by some angle in the anti-clockwise sense. Anti-clockwise sense means like this, right? Correct?
So how do we understand its anti-clockwise rotation?
You don't know the meaning of anti-clockwise or clockwise?
No, sir. I know, but sir, like it says that rotated by tan inverse 24/7.
Said anti-clockwise, dude. You have to read the question.
Oh, okay, sir. Sorry, sir.
Question नहीं पढ़ोगे तो कैसे होगा? Right? It is mentioned there, no, in the question.
Yes, sir. Yes, sorry, sir.
So you'll take this line and turn it by that much angle, right? So maybe let's say it looks like this now, right? Do you understand what I'm saying?
Yes, sir.
This angle would be the alpha is equal to tan inverse 24/7, correct?
Right, sir.
Right.
Yes, sir.
And I have to find this is my L2, this is my L1. I have to find in center of this triangle, correct?
Correct.
Okay. My triangle is clear now. Y-axis is this, right?
Right, sir.
Okay. So it is obvious that the vertex here would be minus 0, comma minus 3. One vertex is what? Minus 4, comma 0,
Zero.
right?
Yes, sir.
And if we knew the third vertex, in center formula is only obvious, right?
Yes, sir.
So all we have to do is find the third vertex then. Right. So think about it. This line was having what slope? Slope was minus 3/4, right?
Minus 3/4. Yes, sir.
And that would have been the tan of this angle. Do you understand?
Yes.
Tan of this theta, this angle, should be minus 3/4, right?
Right.
Now notice that I have turned by a particular alpha angle here, right?
Yes, sir.
So I can figure out the beta angle that I want, right? This beta is what I want, correct?
Yes, sir.
So what we can say is theta. If this is theta, this much is pi minus theta, right?
Yes, sir.
Pi minus theta. And if this is alpha, I have to do what? Alpha minus pi minus theta, right? Do you understand what I'm saying?
Yes, sir.
Alpha was my total rotation, this much, right?
Right.
And pi minus theta was this much, right?
Yes, sir.
If I subtract the two, I should get my beta, right?
Yes.
Which is the angle with the positive x-axis of L2. So this should give slope, right?
Yes.
Okay, so I have alpha plus theta minus pi is equal to beta, and I have to take tan. So tan of both sides, tan of alpha plus theta minus pi is equal to tan beta, right?
Right.
So this can be written as minus of tan of alpha plus theta. You can simplify the basic trigonometry, right?
Right.
Take a negative, you can make it pi minus something, right? Okay, it will become plus. Do you understand why? What I'm saying is, it is like saying this, tan of theta minus pi. That is the same as negative of tan of pi minus theta, because tan is odd function.
Yes.
And tan of pi minus theta is same as minus tan theta. So minus minus becomes plus, right?
Oh, yes, sir.
Do you understand what I'm saying?
Yes, sir. Yes.
So I am able to say that tan of alpha plus theta should be equal to tan beta, right?
Right.
So now it is obvious how to find that now, right? It is simply tan alpha plus tan theta by 1 minus tan alpha tan theta. Correct?
Yes, sir.
I already know tan alpha is 24/7. I already know tan theta is minus 3/4. Right?
Yes.
Divided by 1 minus minus. So plus 24/7 into 3/4. So this becomes 96 minus 21. So that is 75/28 on top. 75 by 28. Whole thing is divided by, this is 6, 18 by 7 plus 7 by 7. So 25 by 7. Right? So that becomes again 3 by 4. Right?
Right, sir.
So this angle, tan beta is 3 by 4, right?
Yes, sir.
If tan beta is 3 by 4, equation of L2 is simple. It passes through this point and is having slope of 3 by 4. So y minus 0, so y is equal to 3 by 4 x plus 4, right?
Yes.
Find this vertex. It is very easy. Put x is equal to 0 here. You will get y is equal to 3. Correct?
Yes, y is equal to 3.
So now we know all the vertices, right?
Yes, sir.
Notice that this side is having length of 5. This side is also having length of 5. So it's an isosceles triangle. Correct?
Yes, sir.
And basically angle bisector will be also perpendicular and all, right?
Right.
Angle bisect, it feels like it will come somewhere on this line. So, and this length is 6, by the way. So we can directly put a formula ax1 plus bx2 plus cx3 by a plus b plus c, right?
Yes, sir.
You know this formula for incenter, right?
Yes, sir.
So notice the side here is 5. So opposite vertex is 0 for x. You get 5 into 0
0.
plus 5 into 0
0
plus 6 into minus 4.
minus 4.
So minus 24 divided by 5 plus 5, 10 plus 6, 16.
16.
Minus 3 by 2. Right?
Yes, sir.
That is the x coordinate, similarly y coordinate, and then find the answer.
Right.
Do you understand how we have done the question?
Yes, sir.
Again, if you don't draw the figure, you will get stuck. You have to draw line L1. You have to figure out where you do the rotation. And once you do the rotation, I didn't do any more big theory like, okay, how to find rotated equation of a curve. There is theory for that, by the way. But this is such an easy question because it's just a line and some angles, right?
Right.
By the way, if the question had said, I have a curve that looks like this parabola, and then I rotate the axis by something, then what is the new equation of the parabola, right? If a question was like this, then I have to do theory of rotation about an axis. Basically, what do I mean by that? Anytime you rotate the axis by a certain angle, your new x dash and y dash can be written in terms of the old x and y, right?
You're right, sir.
If you don't know about this, you have to watch. There are videos on this in my channel, okay? Find the video, search for rotation and all. In the coordinate geometry playlist only, it will be there somewhere.
Right, sir. I'll watch.
The theory is pretty simple. It takes advantage of complex numbers, okay? So if I have a situation like this is a point x comma y, right?
Yes.
Now, the complex number version of this is r, e, I, theta, where this is r and this is theta, right?
Right.
And that can be written as r cos theta plus I sin theta, right?
Yes, sir.
Suppose I rotate the axis itself, x and y axis are now going to be turned and it will become like this, right? Do you understand what I have done?
Yes, sir.
If I have rotated the axis by an angle alpha, the r doesn't change, but this angle becomes theta minus alpha now, right?
Right.
In our new axis, the point is having an angle of theta minus alpha, right?
Yes, sir.
So it should be in our new coordinates, it should be the point r, e, I, theta minus alpha, right?
Yes.
So it should be r cos of theta minus alpha, comma r sine of theta minus alpha.
Yes, sir.
These should be the x dash and y dash, right?
Right, sir.
The same point is being written as this now, right?
Oh, oh,
Do you understand what I'm saying?
yes, sir.
The same point is now going to get a different coordinate because we have rotated the axis.
Axis, yes, sir.
By simple complex numbers, we can write this. We can say x dash is equal to r cos theta minus alpha, and y dash is equal to r sine theta minus alpha. And we already knew in the beginning x was r cos theta and y was r sine theta, right?
Yes.
Correct?
Yes.
Now you can obviously relate the new coordinates with the old coordinates. It's very easy to do that. You expand this by trigonometry, r cos theta cos alpha plus r sine theta sine alpha, right?
Yes.
So x dash is equal to this. So that is obviously x cos alpha plus y sine alpha. And similarly, y dash also will come. R sine theta cos alpha. R sine theta is y. So y cos alpha minus r cos theta sine alpha. So x sine alpha.
X sine alpha.
So this becomes the equation that connects the xy old x, new x dash y dash to the old x and y, right?
Right.
So if a curve had some equation in the old coordinates, I can find the new equation in x dash y dash for it, right?
Right.
Suppose the curve had equation y square is equal to 4a into x minus 3, right?
Right.
And I have rotated the axis by some degrees. I want the new equation in y dash and x dash for the same curve, right?
Yes.
All I have to do is take these two relations and do the opposite solution. I want to find x and y in terms of x dash and y dash, right?
Right.
Do you understand what I'm saying?
Yes, sir.
If you can find x and y in terms of x dash and y dash, which is very easy, you just solve for x and y here instead of this version, right? How do I solve for x and y? Multiply by, for example, in order to cancel x, I have to multiply by sine alpha here and cos alpha here and add them.
Right.
That will immediately cancel x and you'll get y is equal to what, right?
So we'll get y sine square alpha
Hmm.
plus y cos square alpha is equal to
Huh.
x plus y dash.
So you'll get basically y is equal to
Y
x
is equal
dash
to x
sine
dash plus.
alpha plus
Yes.
y dash
Y
cos
dash
alpha,
cos
right?
alpha. Yes, sir.
Once you get that, similarly, you can find x also, right?
Yes, sir.
Once you find x and y in terms of x dash y dash, in the old equation, you can replace x and y.
Right.
Correct?
Yes,
And you
sir.
will get the new equation of curve after rotation. After the axis was rotated. Do you understand what I'm saying?
Yes, sir.
So this is the standard method of rotation, like what happens to a curve after you do some rotation and all. But in this problem, we did not need to do that. Why? Because we had slopes and all, no? It was just a line,
Yes,
right?
sir. We had the angles.
We already knew so much about, okay, we knew this angle, we knew how much you need to rotate, right?
Yes, sir.
All we had to do was find this much beta. And then we would get the line equation.
Right.
If it was a more complicated problem, I would have done the rotation that I just showed.
All right.
And I would have gotten the equation of that second line by rotation or something. Right?
Yes.
So you should know this rotation theorem and stuff because many times it might be used.
All
Okay.
right.
Is there any other doubt?
No, sir.
Sir, fourth.
Fourth question where? Which section?
Sir, this section only.
Numericals.
Yes, sir.
Okay. A line L having positive slope passing through the point 1, 1 intersects the curves at A and B. Okay. If the lines joining origin and the points A and B are such that the coordinate axes are the angle bisector between them, then equation of line L is given by this. Okay. Fine. So now line L is given by this. Find the. Okay. So equation of line L we already know is ax plus by plus 1. This is line L. And they have said it is positive slope. Slope here right now is minus a by b. So we know a and b have opposite sign, right? Do you understand what I'm saying right now?
Yes, sir.
This line also passes through 1, comma 1. So I can put 1, comma 1 into it. So I have a plus b plus 1 is 0. That is an additional piece of information. Then it intersects the curves. The curve equation is given at points A and B. If the line joining origin and the points A and B are such that the coordinate axes are angle bisectors between them. Great. So this is a direct question on homogenization. The curve is given. The curve equation is 2x square minus y square plus 2x minus 4y plus 2 plus 2x minus 4y plus 2 equals 0. And what they are asking us is information about if this line, the line is cutting the curve twice. So, 1 second. The line should be such that it cuts the curve twice. So maybe the curve I should draw like this so that this line is cutting it twice. A and B. And they are asking us for angle bisectors of the angle lines joining the origin and the points A and B. So OA and OB. OA and OB. The angle bisectors of these two are being asked. My diagram is obviously wrong. Don't have to worry about that. But anytime they are asking us to join OA and OB, and they have given us a curve and a line, the question is a homogenization type of question. If you have never seen homogenization, you need to watch the homogenization videos on my playlist. It is explained in detail. Have you ever heard of homogenization?
Yes, sir.
So pair of straight lines equations I need. Pair of straight lines OA, OB. I need the equations of these two pair of straight lines. I will use this equation and the curve equation that was given to me. So curve equation was 2x square minus y square plus 2x minus 4y plus 2. And I will homogenize it. So to homogenize it, I need to write it like this. This is minus 1. So minus of ax plus by is equal to 1. And I will use that in all the linear terms and this term to make it, all terms should be of 2 degree. I will do nothing to the first two terms because they are already 2 degree. Then I will say plus 2x into minus of ax plus by because that is same as 1. And minus 4y into minus of ax minus by and plus 2 into square of this. This equation is unchanged, but we have used this value to homogenize everything. And now you have to simplify this equation a little bit. So you'll get 2x squared minus y squared minus 2ax squared minus by, so minus 2bxy. From here I get a plus 4axy and plus 4by squared. And from here I get minus plus 2a square x square plus 2b square y square plus 4abxy equals 0. I hope everyone is understanding what I have written so far.
Yes, sir.
So the terms will be, I will collect all the terms of similar type. So 2x square and there is an x square from here and there is an x square here. So these three terms are gone now. 2 minus 2a plus 2a square x square. And y square terms are coming from here, here and here. So we have minus 1 plus 4b plus 2b square y square. So y square terms are gone. XY terms are coming. There are three XY terms. Okay. So you get a XY common 4a minus 2b plus 4ab. Do you see this is the pair of straight lines equation?
Yes, sir.
The question has said that the pair of straight lines, if the lines joining origin and A and B are such that the coordinate axes are the angle bisector between them. Great. So equation of angle bisectors apparently should come out as the coordinate axis for us, right? Angle bisectors of this pair of straight lines. Are you understanding what I'm saying right now?
Yes, sir.
So equation of angle bisectors of any pair of straight lines, the general equation you should know for a general pair of straight lines, this is theory. It is x square minus y square by a minus b is equal to xy by h. Do you see? Have you seen this formula before?
Yes, sir.
Yes, sir.
You should know this formula. It is standard formula. But for us, our a is this, our b is this, and our h is half of this, right? Correct? Because this formula was for ax square plus by square plus 2hxy. For that equation, this formula was derived, right?
Yes, sir.
I hope you are understanding what I'm saying. You should get bisector should be a minus b, this minus this. So subtract it, you will get a 3 minus 2a plus 2a square minus 4b minus 2b square is equal to xy by h. H is half of this, so 2a minus b plus 2ab. Correct? This should come right.
Yes, sir.
So if this equation is supposed to represent the equation of the x is equal to 0 and y is equal to 0, then what needs to happen is the denominator should become 0 and all. Then only you will say that xy should also be 0, right? How will this become the equation? The lines that come from here have to be 0, no? Both the denominator should be 0. Then only you will get x is equal to y is equal to 0. I hope you are understanding what I'm saying right now.
Yes, sir.
Suppose one of the denominators was not 0, then it is not guaranteed that you will get x is equal to y is equal to 0. Okay. Think about it, you'll realize that.
Yes, sir.
If any of the denominators is non-zero, no, it's not guaranteed that the lines will be x is equal to y is equal to 0. So now you
If the
have,
first denominator is not 0, then can we say x, y, or x is equals to 0 and y is equals to 0?
it's not guaranteed then, no, because what we are getting is, you are getting second denominator is 0, then you have,
X, y is equals to 0.
but that can be true even when x is equal to 0, but y may not be 0, right?
Yes, sir.
For both to be equal to 0, it's OR, right? If just xy is 0, then you don't know both are 0 or not, right? Do you understand what I'm saying?
Yes, sir.
See, you need to make this also 0 because this guarantees x square is equal to y square, right? If both are 0 together, xy is 0 and x square is equal to y square, then you are guaranteed, no? Do you understand what I'm saying?
Yes, sir.
So put both of them as 0. You also have this condition. So after that, it's a matter of simplification. You have to find the value of 3a minus b, right? So it should be doable. You can write from here, you can say 2a common 1 plus b minus b is 0, right? And 1 plus b is equal to minus a, right? So you're getting minus 2a square is equal to b. And b is equal to what? Minus 1 minus a. So we are getting one equation, 2a square minus a minus 1 is 0, right? Basically, and solve it 2a square minus 2a plus a. So 2a common, a minus 1 minus 1. So a can be 1 or half, right? 1 second. 2a common, a minus 1 minus 1 common, a. Okay, just check it once. 2a square minus 2a plus a minus 1. 2a, a minus 1 plus 1. Okay, 1 and minus half. 1 and minus half are coming. If I put minus half, then b, okay, if a is 1, b is minus 2, I'm getting. A is 1, b is minus 2. And if a is minus half, then b is coming as what? Half, plus half, right? No, b is also minus half. But that is not acceptable, right? That solution is not acceptable because a and b have opposite sign. I hope you're understanding what I'm saying.
Yes, sir.
So we'll reject that case, we'll take this case, and we have to find 3a minus b. 3a minus b is going to be 3 minus minus, so plus 5. Answer is 5. Do you understand the ideas what were involved in solving it? First idea was homogenization. Second idea was once you get the equation of pair of straight lines OA, OB, you need to know the bisector formula. And third idea was for the bisectors to be x and y axis, the original equation of the bisector should have denominator 0 both places. You could have done it in a different way also. If the bisectors are x and y, the slope of the original lines must be plus minus 1 or something, right? Do you understand what I'm saying right now?
Yes, sir.
If the two bisectors are x and y axis, what will the slope of the lines be? 1 and minus 1, right?
Yes, sir.
So m1 plus m2 should be 0 from here only, no? Correct?
Yes, sir.
And m1 plus m2 is equal to 2h by b. So you get this condition anyway. The condition that we finally said is 0, right? And you also have to use the fact that m1, m2 is equal to minus 1. So from there also you can get 2a by b is 0. You can check that condition what comes from there. Or you can follow the method that we just now did. Aditya, are you understanding what I'm saying?
Yes, sir.
Okay. What is the next one? Is there any other doubt?
No, sir.
Okay, fine. That's it for now then. I will try and do one more class if anybody has any doubts in the other sheet. There is one more sheet, by the way, on straight lines. That includes AOD also. AOD, straight lines and circles. 3 chapters are there in that sheet. Have you seen that one?
Yes, sir.
So that sheet also, if there is any doubts, I will discuss in one more class and then we'll start the next set of topics. So please solve the sheets if you haven't done them already. If you have done them, then you can start with the next set of topics. The next week's topics for us are basically differential equations and conic sections. So those sheets also I will share soon, but focus on finishing straight lines and circles and AOD if there is anything left. I will do one more class for doubts on those chapters. Is that clear?
Yes, sir.
Okay, fine. That's all for now then. I'll see you next time.
Thank you, sir.
Mhm.